Hi, this is Thomas. Welcome back. Our topic is integration. In this lesson, we'll learn how to perform integration using the method integration by parts. At the top of the screen, we have the integration by parts formula, which is the integral of u dv equals uv minus the integral of v du. We're going to use integration by parts when we're multiplying two functions and we don't have a relationship such that we can use substitution. Looking at our first example, the integral of x times cosine x with respect to x. Our two functions are x and cosine x. There isn't a function derivative of function kind of relationship that we can work with using substitution, so we're going to use integration by parts. Going to our algorithm, step 1, identify function type. I've identified the multiplication of two functions without the opportunity or ability to use substitution. This will be integration by parts. 2. Apply integration rule. The integration rule for integration by parts at the top of the screen means that we need to identify which function is u and which function is v. I'm going to identify those in this example, then explain how I chose which function to be u, which function to be v. Then we'll apply that rule when we decide the u and the v in example 2. U is going to be x. What I want to do with u, notice in my integration by parts formula, I have a du on the right side of the equation. So I want a du over dx, the derivative of u with respect to x. Looking at u equals x, then the derivative is 1. In the formula, I don't want du over dx, I simply want du. So I'll multiply both sides by dx, and now I have du equals 1 times dx, or simply dx. I also want to identify the v function. We start, notice in the formula, the left-hand side of the equation is the integral of a multiplication of two terms, u and dv. So in our example, the two terms x and cosine x will be assigned to u, which has been assigned, and dv. I'll start with dv over dx, the derivative of v with respect to x. Notice in the product x times cosine x, we've assigned x to u, so what is left is cosine x. And again, looking at the integration by parts formula, the left-hand side of the equation has a dv, so I want to eliminate the dx from the denominator. I'll multiply both sides by dx, and we have cosine x with respect to x. Now notice that in problem 1, we have an x, which is our u, and we have a cosine x dx, which is our dv. One more step in my setup, which is I want to integrate to get to v. In u to du, we are differentiating. In dv to v, we are integrating. We have cosine x with respect to x. The integral of cosine x is sine x. And for now, we're not going to include the constant of integration. We'll do that at the end of our analysis. Now we can set up integration by parts. The integral of u times dv in this example is going to be x for u times cosine x dx for dv, which equals u times v. U is x times v is sine x minus the integral of v times du. V is sine x and du is 1 times dx, or simply dx. And now we have an easier to work with integral than we had when we started. The new integral is simply the integral of one function, sine of x, as opposed to the integral of a product of two functions. So we have x sine x minus the integral of sine x with respect to x. the integral of sine x with respect to x is negative cosine x. Minus negative cosine x becomes plus cosine x. And now we'll add on our constant of integration plus c. Here we've completed step 3 of our algorithm. There's no further simplification required. This is an indefinite integral, so step 5 doesn't apply. And the integral of x cosine x with respect to x is x sine x plus cosine x plus c. Now let's go back and talk about the decision to assign x to u and cosine x to dv. That decision is based on Lipit. Lipit is the order of functions that we want to assign to u. L is logarithmic, I is inverse trig, P is polynomial, E is exponential, and T is trigonometric. The first one I see is the one that I assign to u. Now this isn't a universal rule, there are exceptions, but generally this is the process that we'll go through. So let's look at example 1 to identify where in Lipit these two functions fall. First, log. There are no log functions. 2, inverse trig. No inverse trig functions. 3, polynomials. We do have a polynomial, the x term. That's the first function in my list, so that's what I assign to x. And the remaining function, cosine x, is assigned to dv. We'll end this video here, and when we return, we'll continue with integration by parts, example 2.